Let's do question 4 from our lookalike. This lookalike paper, we like it, right? It's saying we have f of x. Before we put part A, we have f of x being equal to, now we do it. This is bx plus c. Then they say if x is greater than minus 1, then here it is 6x squared minus 3 if x is less than or equal to minus 1. No problem. Now, what are they saying? They're saying now, given that f is continuous and differentiable at x equal to minus 1, determine the values of b and c. What a joke of a question. So easy, because anyway, even if they didn't tell us that it was continuous and differentiable, even if they just said it is differentiable, we know that any function which is differentiable is continuous. Now, the thing of it is, if you ask to check anything to do with the word differentiable and there are two missing letters, if there are two missing letters, then we are going to need two equations. And one of the equations is going to come from our test for differentiability, where we differentiate the less than and the greater than and make them equal to each other. That is the first one. Then the second one is from equating the limits, limit from the left and limit from the right, all the time. As long as you see yourself having two missing things and the word differentiable is mentioned, then we are going to do those two things. Let's do the two things, what I've said. So that is our part A. We are checking at x equal to minus 1. So either way, we are going to say first, when x is less than, we can start with greater than minus 1. When x is greater than minus 1, you have f of x. You can rewrite the f of x before starting. Okay, to do part A, you rewrite it. Then you can now say when x is greater than numbers, f of x is going to be what? When greater than, it's going to be bx plus c. Now you find your f dash x, which is going to be differentiate. Derivative of bx is a b. Derivative of c, which is the number, is 0. Now what do we do? They said we are testing at x equal to negative 1. So you're going to say let x be equal to minus 1. You now find f dash of minus 1 is just going to be, since it's a b, there is no x, it doesn't change. Now you skip 2 lines. You now say when x is less than or equal to minus 1. What is our f of x? F of x is going to be the other one, which is going to be less than or equal to, it's 6x squared minus 3. So it's equal to 6x squared minus 3. Then now we find our f dash of x. What is it? Differentiate 2 times c is going to be 2c. Then x is now to the power of 1. Derivative of negative 3 is nada. Then we can say f dash of minus 1 rule. So we're going to say let x equal to minus 1, because that is where we are testing the things. So we can now find f dash of minus 1 is going to be 2c by minus 1, which is going to be equal to negative 2c. Right? This is going to be equal to negative 2c. Now we have this. Now you can say for differentiability, at x equal to minus 1, you're now going to say f dash of minus 1, where you can say when x is greater than minus 1 should be equal to f dash of minus 1 when x is less than or equal to minus 1. Okay? Even if it was f dash of 6 here, a differentiability at x equal to 6, you're now going to say f dash of 6 when x is greater than minus 1 should be equal to f dash of 6 when whenever. Okay, so what is the f dash of minus 1? Because we're testing differentiability at minus 1, that is why we differentiate and we put that minus 1 inside the derivative. And what did we get? When it is greater, f dash minus 1, we got it to be b. So you can now say b is going to be equal to f dash minus 1 when it's less than or equal to, we got it to be negative 2c, which is here. So we can say we have found that b is equal to negative 2c. This is our equation number 1. Okay, you can put here to say ... 1. Now to get our equation number 2, you're just going to say what is the limit as x approaches, what is the value here? Negative 1. The value, you use the value where these two functions are coming together. Okay, you just use the value where these two functions are coming together, and that is at minus 1 here. That is where they are coming together. You use this. So it's the limit as x approaches minus 1 from the left of f of x. This is now going to be equal to the limit as x approaches minus 1 from the left. You just put that. You just start by doing this. What is our f of x? If we're coming from the left, that means we are less than minus 1. So it's going to be 6cx squared minus 3, okay? Because that means we are less than, because we're coming from the left. Now, how do you solve this limit? You just substitute. So it's going to be c by negative 1 squared, then minus 3, which is negative 1 squared is just a 1. So it's c by 1, then minus 3, okay? Which is going to be c by 1 is just a c minus 3. So it'll be a c minus 3. Then we can now say what is the limit as x approaches negative half from the right of f of x. This is just going to be limit as x approaches 1, negative 1 from the right. What do we take? We're coming from the right, so we are bigger than minus 1. We'll take on our piecewise, we go back to our piecewise. If we're bigger than minus 1, we're going to take this one, bx plus c. So it's going to be of bx plus c. What do? It's a polynomial, you substitute. So where there's x, you're putting that. So it's b by minus 1, then plus c, which is negative b plus c. This is going to be the limit. Now, what should we know? The limit have to be the same. So you can say limit as x approaches minus 1 from the left of f of x. You are going to say let, okay? Because they should be the same. So you're going to say let the limit as x approaches minus 1 from the left of f of x be equal to the limit as x approaches minus 1 from the right of f of x. What are the solutions? The one from the left is c minus 3. So c minus 3 is equal to negative b plus c. Which from here, we can now just have c come to this side. We have c minus 3, then minus c equal to negative b. C and minus c, they'll cancel. We have minus 3b equal to negative b. And that means if we say divide by negative both sides, we have 3 equal to b. So we can just say b is equal to 3. And here is our final solution for b. We have b, but now we need to just go and put c. We have here b is negative 2c. So we can say, yeah, that b is equal to negative 2c. So that means now b3 is equal to negative 2c, which we see negative 2. It's going to be, so negative 3 over 2 is equal to c. And it's done. This is going to be the final solution. And we have both b and c, and we are done. So once we have b and c, we can do part b, which is going to be done in the next video. Goodbye for now.